I put these things on YouTube so that we have some record, and then I have to report statistics back up to AWS and GCP about what I'm doing.
Yes.
Awesome.
So okay, so we did all of this, so we're kind of using that as a guide, but we're actually doing. Where is the TensorFlow notebook?
No,
Yeah,
MXNet.
MXNet. Yeah, I'm looking for it. MXNet. Where's that notebook at?
And we will not only see one ear.
Yeah. Okay. Because this is MXNet. That's the original example. Where is the actual? It's down here. Okay, here we go. I got too many
Screen.
browser tabs open.
Yeah.
Okay, so this is what I was using as this is the example that I'm running down here, but we're doing this. This was kind of like the right thing. So let me hold this here. We're actually running out of a SageMaker Studio.
Excellent.
This code that's here is from there's a Coursera class that's taught by people from Amazon, and it's on Gluon CV. Gluon CV is a higher level piece of the MXNet from Apache. So
Is it a good course?
I thought it was a real good class. I took it probably 2 years ago, and I I've been trying. I used to actually make money doing TensorFlow, believe it or not, and I've never made any money with uh, MXNet. But I took the class, and I was like, "Oh, I like it," because I have an interest in image processing, and I have an interest in machine learning, but I don't work in it. But anyway, so here's where we're at. So this is the International Women's Day thing, and the whole point of all of this work is uh, to learn enough about the presentation so that OpJ can give a talk for GCP with TensorFlow and MXNet for AWS. And it's kind of just something to do, try to get our chops up again.
Oh yeah.
All right, so here, let's go ahead and get this started. So if I remember correctly, while that's installing, all right.
Yeah, it looks like it's done there.
So I'm just looking to make sure the stuff that I did before. Basically, this is kind of a blend. Some of these imports are what I was doing for the IC bridge, and then some of these are literally for the class. So we've got the libraries installed. It looks like they have some different imports. Oh, okay. And also, this is some stuff from before. Probably ought to get all this stuff in the same. They put in some different paths here. Okay, so they did a data directory. I had to adjust some paths because when it's in this thing, it's a little different. Let's make sure this is right. That's right. It's the same data set. It's the fashion MNIST.
I see it.
All right, and they're doing this. this was this was part of our problem that we had before was I couldn't figure out how to do this just by looking at the notes. But let's look at this a little bit better. So so I was loading the data set, and then let's go up here. This is where it was. I was loading the data set. It comes out as a gzip. So train data is literally a gzip. And then they were doing this transform and then turning it to a tensor. So let's look at and see what this does. How does this guy take gzip code and then put it into a tensor? Let's see how that does, how that works. Because like here is the code for that data set.
Yeah.
There's see the same, it's saying the same thing. It's just the gzip. So let's go to transform. See if we can find that. It is transform first. Okay. So since that was a data set, the thing that we were looking at before, this is, I guess, an interface function from that guy. And so you're not having to tell it that it's gzip. They must be just working off of it, right? And this is the first element.
Now, do you think the problem is that it is a gzip? That's why it's doing that?
No, what I'm trying to convey, and I'm not being very clear, is that this guy. So when I was looking at it from before, and I was like, okay, here's the function to get that data set. I was like looking at it, and I was like, oh, well, this I don't understand what am I going to do now, because it's a gzipped data. It was a little different from when you looked at over here with TensorFlow. TensorFlow had the same kind of class. Where are we? Right. So you would tell it, you would give it a data set that's in the API, and it would automatically come out like so, because they, under the covers, they're taking the gzip
Yes.
and they're returning it at one piece. When I looked over at the code that we're doing here, it was like, well, this is gzip. How do I get out of it? But what happens is, because this is a class of the data set, and that data set class has this function transform first and transform, it looks like that Python code beneath the scenes, because it's, literally it's a function, right? It must be able to say, oh, I've got stuff that's in gzip form, and then I will turn it into an array. And then let's see, what's the difference between transform and transform first, just for grins. Returns a new data set. And the transform function is probably sent to tensor. Yes.
Yep.
So very good. I don't understand what the first and the regular is.
It looks like the first, it keeps saying that the first is a new data set with the first element of each sample transform.
Yeah.
What does that mean? This is useful example.
I don't know. So we can say transform and transform first. Let's see what we could actually just run the difference. just to see what happens. Do it that way.
Yeah. Good old trial and error.
Yep. Yep. Indeed.
Yep.
We'll call this 2, and we'll just get a listing of them.
Mm-hmm.
Let's leave them both in there for now. Sample data, and we'll call this 2. That's the only difference, right?
It is. Let's see. Came up with something you didn't like.
Okay. So I think what's happening is that's it's only like one image. I think that's what's happening there. Because if we were to go, let's go to here. Yeah, so that's just, it's a 1 pixel, 28 by 20. It's 28 by 28 pixels of one value. If we were to do on this guy, he's probably 3 layers. And there's takes 3 positional arguments, but 4 were given. 3, which one? Because right off the bat, let's do this. Test data set and test data set 2. Has no attribute shape. Let's just do what this is for a second. I heard a beep. Is that chat here? Is that no one joined? Okay. Just a lazy transform object. So he's not actually, it's not being interpreted. Okay. All right. Well, I'm not really sure, folks, what the difference is. I keep hearing beeping. It's in Slack, maybe? Give me a second. Someone might be trying to join. No, I'm not sure where it's coming from. All right, well, whatever. So we'll just go with transform first. We'll look at that later because I really want to get to the meat and potatoes of this. Okay. What's I doing next? Just saving off some of my notes. We don't want this to be code. We want it to be markdown. So this is the same kind of thing they were doing from before. If we were to look at, let's get rid of this. If we were to look at print. You can see that it's floating point numbers. And let's take this one out. Oops. Array.
Are you ready?
Like so. And let's just pick a random position. 13, 12, see if we can see a float. There we go. So it's a float, and then we should be able to actually see it's a float type. Actually, it doesn't even matter. Just do one. Is he still saying the array type? Part of the thing is, like with MXNet, it's evaluated, whatever, yada yada yada. But print, it's supposed to show what it's evaluated as, and he's just showing that. Maybe if I do like so, maybe like this. There we go. Now we're afloat. Okay, good. All right, so let's get back to the example. What are they doing here? They're going to use another API, the data loader API. And I think that's because this stuff was this lazy transformation.
Yeah.
Lazy equals true. Yeah. Okay. You can see this is my homework because I see like your code here, right. So all this is doing is it's just taking those images and it's going to, let's see, get average image from batch. The NCHW is number of channels. Pardon me. N is number of the batch. C is the channel, and then height, width.
Okay.
And you can
I was
see,
wondering what that was.
right? And so you can see this is, you're saying 1,000 images or 1K images. This is the actual dimension, which is the color, and these are the two dimensions for the X and Y.
Yeah, for the array. Okay.
If this was a 3, it would be a red, green, blue image.
Got it.
And so that's that. Part of my reasoning for doing this, trying to, because I don't remember a lot of stuff I was doing with MXNet, and it was a class, so you're kind of glossing over some of this stuff. So this is the average image. I don't know what the use of this would be. Right? Get average image from batch. Ah, okay.
Did you find something?
All I'm doing is looking through. So way back when I took this class, I had my stuff saved off in Git. I'm literally just using it as a template, and I'm redoing it. Right. The reason I'm doing that is because for like the for the TensorFlow, they have a tutor, right, in the beginner section, basic classification, classify images of clothing, and they're stepping through this data set, right? And I'm literally just saying, like, well, how do I do this with MXNet? And when I went to look at some of my old code that I used, I noticed, oh, there is I've actually done this before. But like I said, it's been a while. All right. So, and then what he's going to do here is he's going to normalize those images by probably dividing it by the average image. They didn't do that in the other one. I don't think this is necessary, but he's not dividing it. He's going to subtract it. So every image will have this subtracted from it. And this is going to be a markdown. Since I just started doing this, it's like taking me a while to come up to speed, and I don't know jack at the beginning, but I'll know later the more we do it. And then what did I do? I did this. So that's subtracting a sample from that average sample. And then here it's taking it, turning it into a NumPy array, and then he's plotting it as NumPy. What's odd is, why does he have to do this as NumPy twice? Because this is not an assignment. That's just testing to see if they're almost equal. That's just an assert. This 0 corresponds to that guy there. Like I said, if that was a 3, it would be red, green, blue. And then you could say like 1 would be green, right? 2 would be blue. These are coming up this way because he doesn't have a CMAP and he's thinking that's a color image. I think if I do, it will look better. Yeah. This is just code that I do as notes. It's weird. I think the reason I did it this way was so that I would get it to look, like each line. And that's because this is a batch. Now I've got stuff that's like, just, I can tell I'm like really going off in the weeds here, but this kind of explains the array. Like I said, I'll clean all this stuff up. So here is a 2x2 image, another 2x2 image, another one, another one. They're for a total of 4. So that's 4. And they are 3x3. So it's supposed to be 3. It's supposed to be like a 2x2, 4 images that are 2x2 of a red, green, and blue. And let's see if I can see how this works. This would be like the red. This would be the images of green, and this would be the images of blue if I was trying to do that right. And then let's see, did he have means and sums in here? He did it as a sum. I've got some notes here. I'm just looking at this, seeing if any of this is valid. I think what I was trying to do was figure out how to use the mean versus summing it and dividing them. And it's the same. So let's I'm back to. I'll probably cut this out, but let's see what we've got here. Yeah, that's no big deal. Okay. Yeah, sometimes I have things that are a little more simple and I know more about what I'm doing, so you got to bear with me. What was I doing here? This looks like this was something that was part of the assignment to make sure that to 5 decimals you had the channel average correctly calculated. That's all that looks like that is. It's the same number, just done a different way. This is a lot harder than the one from the TensorFlow thing. All right. didn't have to do this with TensorFlow. So let's see. Channel standard deviation is this. How did I get 0.31? So normalize, you have to have the mean and the STD. And I guess they gave us that because I don't see me calculating that any place. If you guys know anything about normal distributions, you know, it's basically a curve. It looks like this, and it on a, what is it? I think it's the normal one. The normal one goes up to like 0.4, and if you the higher this number is, the more peaked it is. So it's like, you know, like a high. Is that right? No, a low standard deviation is it's very high peaked. A high standard deviation is like low and spread out. I make sure I got that right. Standard deviation. It's the variance, square root of the variance, and know that. And the variance is just how much it varies. So yeah, so here's a standard deviation of 10. It's a low number. Low number goes higher. It doesn't vary as much. A higher standard deviation, it's lower and more spread out. And I think it's 0.4 for a normal distribution. Someone like Ted would know this better than I would. Where's the Wikipedia? So here's a variance of 1. Yeah, and he's like 0.4. So I think that's what's called the normal distribution. These are standards, but the variance and the mean is off. And just look for grins. So lower number, higher. So here's a lower number. It's very high. Here's a high number, and he's very spread out. It's not a peak. And all of these, for what it's worth, if you guys are trying to keep in mind, the area under the curve sums to 1. So I think what they're trying to do over here is they're trying to normalize the data so that all of the features, which in this case pixels, are relatively the same value. And then so here he's going to print what this looks like as layers. So taking it to tensors and then normalizing it. And that's what the compose does. So this is kind of like a mini DNN. It's almost like the Keras stuff over here, where they are building up the DNN, where it's fitting it here, sequential. So you're having your input layer, and your output layer, your hidden layer, and then your output layer. Same kind of thing that they're doing here, but this is not a DNN. This is just using a graph in order to normalize. All right. So it looks like as he's downloading the data, he's now doing a transform to average them. And then here he's shuffling them to get your training data. He's not shuffling the test data. He's got some batches, yada, yada, yada. All right, let's see what we're doing here. Just kind of marking this up, make it look kind of the way I did it before. It looks like he's just looking at what the labels versus the predictions are. And I remember talking about this TQDM. I remember we loaded that, and I made a note on what that is. I can't remember. Python TQDM. TQDM. Oh, it's just a progress bar. That's all it is. Where do I have? It's weird. TQM is a progress bar. All right. And there's a progress bar. Have we built? I mean, like the only thing we did was transform it. So why would they? Oh, here. Okay, so here's the network. The network literally just has an output of 10, and it's like so much different. I don't even see how he's doing the input layer. So this is this going to evaluate and train? I can't remember. God, I don't remember what I'm doing, folks. I don't remember doing this stuff. Should probably watch the videos. What is it? TensorFlow MXNet is instance. this ain't going to allow me to jump between stuff. Let's see what he's doing. It's not telling me anything. Oh, it's a type. It's making sure things are a type. So he's making sure. So what he's doing is he's making sure that this thing that we calculated is of this type or a thing. Okay. Okay. And it has a name and a it's weird. This I got a new keyboard and I'm still learning it. The keyboard has a home key but doesn't have an in key. And that doesn't do it. Let's see if that doesn't do it. Let's see if that doesn't move them to end. It doesn't move them to end either. So I don't, it's kind of weird. Accuracy. Okay. All right. So that was a lot of stuff just to normalize the data, which seems kind of weird, but that's MXNet's different. Here we're really going to build a DNN. All right. So let's look at it for a second. This is the output layer. They're doing two layers, so in the TensorFlow one, they did one of 128. Here they're doing 16 and 8. What's interesting is they don't show the input layers, and I guess they get the input like they infer. Like if it's a 28 by 28, that's 768 features, or 768 columns of data. I think they just like automatically determines that. Looks like they've got some asserts to make sure that you've built things correctly. So is it 3 layers? Yeah. We can print this thing out again if I see how to do it up here. Print transform. Let's see if we do that. Let's try to print network. See if it shows it. Yeah. Kind of neat how you can do that with MXNet. All right. With your network now defined, sounds like we got 10 minutes to go. So let's see. Let's look at this link. Use this guide. Use this guide here. Yeah, right here. We defined the network architecture with no regard to the input dimensionality. That's what I was saying. I need to look at this some more. I'll come back to that. So I think what I don't know what init Xavier is, but I was expecting him to say like, here is the actual data from the MNES data set. And I can see now, going back, how this class was kind of guiding you. You had these asserts that you had to pass. And since that thing said Xavier, that's how I figured out to make this a init Xavier. What that is, I don't know, but I'm just like looking at the asserts, right? All right, and now I'm just kind of copying and pasting some of the stuff. Markdown, Control V. Now, I don't remember what summary is. At least there, he's giving it data, right? And so now, let's see what happens if we print network now. See if it changes to have an additional layer. It does. So when we printed it up here, it was 16, 8, and 10. Nope. Ah, okay. So this thing here is determining what the inputs are. So we're at none, none, none. Now it's 768. going to 16, and then that 16 goes to here, that 8 goes to here, and that gives us our 10. So that's what's going on different. Okay, interesting. The none for input is filled out 768 pixel values for first layer. Compare I didn't have any of this kind of stuff. I was just going with it and didn't know what I was doing. I definitely didn't print that stuff out. Up here, we printed the transform, but we never printed this network here. Okay, where do we leave off? Network summary data. So he's training again. All right, we're gonna leave it right here. So what they're doing now in this homework assignment is they're building a convolutional 2D network, or layers that are convolutional 2D with max pooling, and that's a lot more sophisticated than what we were doing in the TensorFlow one, which is kind of cool. We got like 3 minutes. I'll turn off the sharing, make sure this is saved. Okay, so one of the things is this, I've got the GitHub repo for this, and we need to make sure that over here I didn't do this. I need to save a copy in GitHub. Make sure he's saved there. Yep. I'm going to change this. I'm going to stop streaming in a second, just real quick.
It's the end.
Yeah. I want to make sure that's there.
Well, it will end now. I see you next week then, when it stopped.
Yeah, it's got like 2 minutes. So make sure this is right. So we saved that. Yep. All right. And then over here, since this is in save the notebook, it's in the studio lab. It's there.